recording.
Welcome to our math final project by Phoebe and Alexandra Stewart.
The scenario is this. You are 3 days away from losing your house due to debt. You have tried everything to raise enough money to stay, but you are still short $10,000. The bank has refused to offer you a loan, and so you are left scrambling. You remember that your cousin Joe owns a casino in Las Vegas, so you decide to use the last of your savings to fly over. When you get there, your breath catches at the magnitude of the city, but you have no time for gawking as time is fastly ticking away, bringing you closer and closer to homelessness. You walk 2.5 miles to the casino. In the doorway stands a scraggly man with mangy hair. You are related. This is Cousin Joe. And through his casino, you will make enough money to keep your modest townhouse, or so you hope.
You decide to play a dice game at one of the tables. You must roll 3 dice and bet on the outcome. That's the game. If you bet right, you can win enough money to save your house. The first thing you have to do is find out how many possible combinations you can get when you roll 3 dice. In order to find this out, all you have to do is multiply 6 times 6 times 6. Why? Each dice has 6 possible outcomes when you roll it. If you roll the dice 3 times, there will be 6 possible outcomes each time. Therefore, you multiply 6 times 6 times 6, which equals 216 possible outcomes. But wait, you're not just rolling a dice 3 times. Imagine if that's how casinos worked. Everyone who understood probability would win. One of the rules of the game is that you cannot repeat numbers. That means you can't just multiply 6 times 6 times 6. You're still rolling 3 dice, but once a number is rolled, you can't roll it again. How many possible combos are there now? In order to find all possible combinations of numbers when you can't repeat, you must multiply 6 times 5 times 4. Why? Well, this is actually part of a factorial. Factorials look like 6 exclamation point, which represents 6 times 5 times 4 times 3 times 2 times 1, which equals 720. But hang on, this isn't the final answer to our problem. I bet you're getting frustrated now. You've done the factorial, so how is this wrong? Well, this type of problem uses something called the fundamental counting principle. Basically, although the factorial goes all the way down to 1, 6 times 5 times 4 times 3 times 2 times 1, you only count 6 times 5 times 4 because there are only 3 dice. So the total possible combos for the dice are 6 times 5 times 4, or 120 possible combos. Okay, now it's your turn to bet. You decide to bet that you are going to roll a 1, a 2, and a 3 in any order. Before you do, you decide to figure out the probability that you rolled those 3 numbers. How do you do that, and is it worth the roll? Now, you know that you have 6 options whenever you roll a dice. So the probability of you rolling a 1, 2, or 3 on your first roll is 3 out of 6. Good odds, right? Don't forget, though, that you have 2 other dice. What does this mean, and how do you find the other 2 dice? Let's say that you roll a 1 on your first die. What does that mean? Well, it means that you still have to roll a 2 and a 3. The probability of you rolling a 2 or a 3 on your next round is 2 out of 5. Ooh, less of a chance now, right? Why? Like you calculated before, you can't repeat. So you have 5 numbers to choose from, minus the 1 that you've already rolled, and 2 that you want, 2 and 3, or 2 out of 5. Now let's figure out the third dice. Let's say you roll a 2 on the second dice. Okay, now you have to roll a 3 no matter what. The probability that you roll a 3 is 1 out of 4. These odds just keep getting slimmer and slimmer. Why? Remember, you can't repeat. You only have 4 numbers you can still use because you've already used 1 and 2. And you have to get only one of them, 3, so it's 1 out of 4. You're not finished yet. You have the probabilities for all the dice, but now you have to put them together. Now you're going to use something called an independent event. This is how you determine probability when there are multiple variables. These events are independent events because one occurrence has no effect on the other. You can roll a 1, 2, or 3 in whatever order you want, and you also can't roll a 1 and 2 at the same time. So you multiply these events together. This will look like a 3 out of 6 times 2 out of 5 times 1 out of 4, which equals 6 out of 120 or 1 out of 20. You have a 1 in 20 chance of rolling a 1, 2, and 3. These are scary odds, but your dealer is glaring at you now. You take a deep breath and you roll.
You watch carefully. First, a 1 appears. Next, a 3 falls. You watch, heart beating fast as the dice rolls on its corner. It lands. It's a 2! You jump up and down for joy, hugging all of the rich people next to you. The dealer hands you the chips that you have won. As you look down, your heart sinks. You've only won $9,000. You still need $1,000 more to keep your house. Good job. You give yourself a not-so-metaphorical pat on the back as you congratulate yourself for your victory with the dice game. You tell yourself Cousin Joe will be proud, even as you see him pick his nose in the corner whilst eating the cheesiest nachos you've ever seen. Now you only have to make $1,000 more in order to keep your house. You scan the room looking for another game to play. Your eyes land on Yahtzee and you almost squeal in excitement, but you muster up all of the restraint and restraining of a body as you know that grandfather time is running fast on the treadmill of your life. You only have time for one more game. You slide over behind someone playing poker and your eyes widen as you see the amazing hand they have. Unbeknownst to you, the other player was watching you.
The guy in front of you loses, confusion clouding his features. You walk away quickly to go grab a glass of sparkling water. As you sip on the bubbly drink, the winner of the poker game saunters up to you and shakes your hand. He thanks you and asks where you are from and what you are doing here. You tell him, and he looks you up and down and says, "You know what? I'll make you a deal. I am an esteemed math professor in Utah County, Michigan, and if you can answer this question correctly, I will give you the $1,000 for your house." Excitement and fear seize your heart as you know this is your last chance to save your home.
Alrighty, the math professor says, here is your equation. The limit as x approaches 3 is represented by the equation x minus 3 over the square root of x plus 1 minus 2. As you solve it, he glances at you, a knowing look in his eye, and cold sweat starts to drip down your neck.
As you look at the problem, thinking about how you're going to survive off of sunlight and greenery for the rest of your life, a blazing bright light flashes and launches you into a detailed vision. A vision that just so happens to show you in HD the step-by-step process of how to do the very equation you're looking at. Almost as if someone solved it for you and you actually don't exist at all.
All right, so here is how you solve this equation. So limit as x approaches 3 is represented by the equation x minus 3 over the square root of x plus 1 minus 2. So the first thing you have to do is you have to get rid of that square root in the denominator, because you can't just plug in 3 in that or else it would equal 0 on the denominator, which is impossible. So you're actually going to multiply it by the reciprocal to get another denominator that isn't a square root. But because you do that, you also have to multiply the numerator by that reciprocal. So you're going to multiply it by x, the square root of x plus 1 plus 2 over the square root of x plus 1 plus 2, which is actually just 1, but you're multiplying that to get rid of the denominator. All right, the limit as x approaches 3, once you've multiplied these together, is x minus 3 times the square root of x plus 1 plus x minus 3 times 2, all over x plus 1 minus 4, which is just x minus 3. Now that you have x minus 3 in the denominator and the numerator, you can divide the numerator by the denominator and get rid of all the x plus 3's in the numerator. So once you've done that, you're going to end up with the square root of x plus 1 plus 2 as the limit approaches 3. As the limit as x approaches 3 is equal to the square root of x plus 1 plus 2, you can now plug in 3 into x to find your final answer. Once you plug in 3, it would be the square root of 3 plus 1 plus 2, or the square root of 4 plus 2, or simplified even more, 2 plus 2. So the limit as x approaches 3 would be equal to 4.
You are thrown back into reality,
Astonished at the luck of it all. You look at the mathematician and he simply stares back at you. Good, he didn't notice anything. You cough slightly to signal you are done and present him with your answer. As x approaches 3, y approaches 4. He looks at you, ever the poker player. His expression is incredibly blank. Finally, when you are about to run over to Cousin Joe and rip a plate of nachos from his greasy hands in frustration, Mathematician Man nods and reaches into his back pocket. He pulls out a wad of cash stacked high. Your jaw drops. You hurriedly thank him and take the money. He nods again and walks outside to grab a cab. As you make your way to the exit, counting your cash, a horrible realization washes over you. It was Monopoly money.
The end. Yay.
Yay! That was our math project of 2021.
COVID edition.
COVID edition. Yeah, this is very COVID edition. Alrighty, I'm going to stop the recording now.